Welcome to the fourth and the last PowerPoint for the carbonyls topic. Here we're going to look at how you test for carbonyl compounds. The textbook page references are 460 to 462. And as usual, as you work through the PowerPoint, make sure you do pause for reflection when suggested to process what you're learning. And if you need any help at all or clarification, do ask your tutor for that help. Let's make a start. We're on page 8 in your notes or 460 in the textbook. Remember, if you haven't got a copy of the textbook, you have got access to it on Carbonyl.com. You can get extra practice questions in there as well. Okay, so testing for the presence of a carbonyl compound, we can use a simple chemical test. So just highlight simple chemical test. What we mean by that is it's something that we can do in the lab using test tube reactions, for example. So maybe draw a line to it and you can just put test tube reactions in the lab. Okay. So we can use a simple chemical test to identify the presence of a C double bond O. So again, identify the presence of a C double bond O, but that's only in the carbonyl compound only. So this test won't detect the C double bond O's in other functional groups such as the ester or the carboxylic acid. So if you have some chemicals and they're unknowns and you suspect that it could be an aldehyde or a ketone, or you're wondering whether it is or not, you need to rule it out, then you can use this simple chemical test to detect them, okay, detect the presence. So the reagent then for this, 2,4-dinitrophenylhydrazine, 2,4-dinitrophenylhydrazine. Now that is a bit of a mouthful, so it's often referred to as 2,4-DNP or 2,4-DNPH. So 2,4-dinitrophenylhydrazine is the reagent, that's the chemical that you would add. So let's say, for example, you had a test tube and you put in, let's say, 2 centimeters cubed of your unknown organic compound, and you wanted to test whether it was an aldehyde or a ketone, you know, whether it was a carbonyl compound, okay, you wanted to check if it was a carbonyl compound. You would then add some 2,4-DNP, and you could do that in the lab at room temperature. And then just give it a shake, so put the rubber bung in on the top and just agitate it. And then let it settle and see what happens. Now, pretty much instantly, if there is a carbonyl compound present, then you would see the positive result for that by way of an orange precipitate. And you'll see on the next slide it is quite obvious. Okay, so orange precipitate, you need to remember, is the observation for 2,4-DNP, which is the test for the presence of a carbonyl compound. Okay, so maybe just, you know, pull those bits together, test for carbonyl compound, 2,4-DNP, orange precipitate. Let's have a look at this equation then. This shows the reaction between 2,4-DNP and propanol. So propanol is your carbonyl compound. And you can see on the right hand side we've formed a new product. It's a bigger organic molecule and we've released the small molecule of water. So you can think of this a little bit like a condensation reaction. Now don't worry, you're not expected to know the structure of 2,4-DNP, although if you want to pause the PowerPoint when I've finished on this slide, you could try and unpick the name, okay, and see if you can work it out. But yeah, you're not expected to know the structure, but what I would like you to spot here is play and spot the difference, that the C from the carbonyl joins to the nitrogen from the hydrazine. So you end up with the N double bond C. Now this is something that they might do in an exam. They might give you an equation with an unfamiliar reaction like this one, and they'll tell you something about it, and they'll write out the equation so you can see what's going on, and then they'll ask you to apply that knowledge to another one. So they'll say, right, okay, so for example, this one, they could say, you know, here's the reaction between 2,4-DNP and propanol. Draw an equation or write an equation to show the reaction of 2,4-DNP with propanone, for example. And you'd be expected to work out, you know, what bonds are being chopped and you know, how you can put those two molecules together and balance it. Okay, so yeah, don't worry about remembering the structure, but what I do want you to remember, and this is the important thing, that product on the right hand side gives an orange precipitate. Okay, you can see it's nice and obvious, you couldn't miss it. Now that orange precipitate tells you it's a carbonyl compound, full stop, that's it. Okay, the orange precipitate from 2,4-DNP identifies the presence of a carbonyl compound. If you then want to prove that it's propanol, you have to do an additional test. So far we've just done a simple chemical test. We've just done a test in a test tube, room temperature, we've shook the reagents together, we've made an observation. Simple chemical test. If we want to identify that it's propanol, we have to do additional tests to allow us to measure the melting point. Okay, so that's what we're going to do next. So we've got our orange precipitate. We know it's a carbonyl compound. That was our simple chemical test with the 2,4-DNP. Now we're going to do some further analysis to identify the specific carbonyl compound. And this is going to involve measuring melting point. Now, measuring melting point is a skill that you will do in the practical endorsement later in the year. But for now, here's a picture of a melting point apparatus that you might see in the lab. Talking you through it very briefly, it essentially comprises of a heater. So you've got your heater here at the bottom, and you can control the temperature of that. So you've got your controls here where you can heat it up, and into that heater block you would put your sample, and it will be the solid that you're going to melt. So here for us it's going to be orange crystals, and we put that in. We only need a tiny amount. We put it in into a little capillary tube, so that's like a super tiny test tube, if you will, and that sits into the heater along with the thermometer. And you're going to record the temperature at which the crystals start to melt and finish melting. Now, how are you going to know? Well, you've got a little viewing window here that's actually a magnifying glass, and if you look into that, you'll see the crystals in your capillary tube, and you'll watch them. Okay, and you'll watch them, and then you'll record the temperature when they start to melt and when they finish melting. Now here's the thing, if it was a pure substance, then that melting point would be very sharp. It would start and finish melting very quickly. If, however, there are impurities in that substance, the melting point range tends to be bigger. So it will start and finish over a wider range of temperatures, and it'll also be lower than the melting point of the pure version. So when we are using melting point to identify the specific carbonyl compound, the crystals that we use are from the orange precipitate. So it's from the derivative of the carbonyl compound. But we need to make sure that they are pure and they are dry before we measure the melting point. Now, why do we measure the melting point? Well, if it's a pure substance, every pure substance will have its own specific melting point. And with these carbonyl compounds, there is a database of those melting points that you can refer to. Okay, So you can measure the melting point of yours and then look it up against that database. And that way you can identify the carbonyl compound. So what I'm going to talk you through next then is the method to be able to do that. But hopefully it'll make a little bit more sense now you've seen the melting point apparatus. So here's our method then to identify the specific carbonyl. This is a model answer, so don't deviate from this script. If the exam question asks you to describe how you can identify the carbonyl using 2,4-DNP, this is what you need to say. You need to say add 2,4-DNP. Now we know we get the orange precipitate then, but what you need to do is to recrystallize that. Why? We need to purify it. So recrystallize the product, the orange crystals, to purify it. Now what does that mean? Well, recrystallization is a process that allows you to purify that solid. And what you'll actually do is you will dissolve, you will filter that precipitate out first of all. You will then dissolve it in a minimum amount of hot solvent, and then you will let it cool down, and when it does so, it forms those crystals again. Only this time those crystals should be pure. Okay, now recrystallization you will do later in the lab. For now, it's the second step of your model answer. Okay, so recrystallize the product to purify it. Then what do? Well, you take those crystals and you measure the melting point. So you measure the melting point. Hopefully it'll give you a nice sharp melting point because you've purified. And then the final step then is you compare that melting point to known values. So highlight those in your notes, that's your method. And remember that's to describe how you identify the specific carbonyl compound using 2,4-DNP. So just to show you then, before we move on, these carbonyl compounds, for example, the equation that we saw previously was propanal. The derivative of that, the orange precipitate, when in its pure form, has a melting point of 155. So if you could measure pretty close to that, that's good evidence that you've identified it to be propanal. Time to pause to check your progress using the learning outcomes on the front cover of your notes. So by this point, you should be able to describe and interpret the use of 2,4-DNP to detect the presence of a carbonyl group in an organic compound. So you know that's the orange precipitate. You should also be able to describe how you can identify the carbonyl compound from the melting point of the derivative. So just check that you're happy with those two outcomes and then press play to continue for the last section. Okay, so this is another chemical test that we can do. So the one that we know so far was 2,4-DNP. We get an orange precipitate if there's a carbonyl present, and we can identify that carbonyl if we measure the melting point of the purified derivative. This test is a little bit different. This one is to distinguish between the two types of carbonyl. So it's to distinguish between an aldehyde and a ketone. Now to do this, the reagent that we use is called Tollens. So Tollens reagent is the common name. Now chemically that is a mixture of two things. It has silver nitrate in, and that is in ammonia solution. In the exam, if they ask you to name the reagent, Tollens should do, but if they ask for the chemical name, I would be tempted to give them the silver nitrate / ammonia solution. Okay, so Tollens reagent is used to distinguish between an aldehyde and a ketone. And hopefully you'll get to do this in the lab. It's something that we do in PAG 7, where we identify unknowns and we're identifying different functional groups. And when you do it, you'll see that you use a water bath. We heat the water to a temperature of about 60 degrees centigrade, and the test will be carried out in a test tube, and we'll get an observation for one of them. One of them will react with the Tollens, the other one won't. Now you can see in the table it says positive result for an aldehyde group. So the aldehyde will react, but the ketone won't. So just pause and have a little think. What do you think is going on? Why do you think the aldehyde can react, but the ketone can't? What do you know about the reactions from previous? What is it that the aldehyde can do that the ketone can't do? Can you remember? So just pause, have a think, see if you can work out what's actually going on here. So hopefully you remembered that an aldehyde can be oxidized where a ketone can't. Previously we've seen oxidation of aldehyde using potassium dichromate with conc H2SO4. Now that was quite a powerful oxidizing agent. What we have here is quite a mild oxidizing agent, silver nitrate in ammonia solution. So it will oxidize the aldehyde. It's not powerful enough though to oxidize an alcohol. Okay, that's important to note when you're looking at considering identifying lots of different organic compounds. So Tollens reagent is really good at distinguishing between an aldehyde and a ketone. It will only cause this positive result for an aldehyde. So if it's a mild oxidizing agent, something in the solution, the Tollens reagent, needs to be reduced. So having a look at what you've got in the silver nitrate, you've got Ag plus and NO3 minus. Now, which one of those two could gain an electron? Because remember, reduction is gain. So Ag plus actually gains an electron, so it's no longer an ion in solution, it's actually the silver solid. And that's what causes your positive result. You would actually see a silver mirror forming on the inside of the test tube. So silver mirror is the common answer for the description of the observation of the test using Tollens. You get a silver mirror when you react Tollens with an aldehyde. So it only happens for the aldehyde, not the ketone, because the aldehyde can be oxidized and the ketone can't be. So remember, the aldehyde is oxidized, the silver ion is reduced. So remember then, reduction is gain. So there you go, the Ag plus from the silver nitrate gains that electron to become Ag solid. So you could say in the exam that a silver solid is formed. They also accept silver precipitate, but silver mirror is a common phrase that we use as well. So just to get this in the notes then, the formation of silver atoms from the silver nitrate tells us that this is a redox reaction. And what's happening during this reaction? Well, our silver ions are being reduced to silver atoms, which is why we see the silver mirror. So the question here, identify what reaction the aldehyde undergoes and suggest a likely product. Well, if the silver ion is being reduced, the aldehyde must be being oxidized. and we know when it's oxidized it turns into a carboxylic acid. So if we're doing this topic before we've done the redox topic in module 5, this is going to be a bit of a stretch at this stage. So what we'll do is we'll make a note of it if that's the case, and you could put a little star next to it and say come back to this after the redox topic on module 5. I may also do a little video clip to accompany this, and I'll put it on YouTube just to show exactly where these half equations come from using our oxidation numbers, okay? But just going through it briefly then, oxidation, they're asking us to use the ethanol for the aldehyde. So here's the oxidation half equation. So notice the organic has changed from ethanol to ethanoic acid. Notice also that there are electrons on the right hand side. It's a product. So oxidation is loss, so those electrons are on the right. So that's what I'd expect you to be comfortable with. The extra bits in terms of balancing, you know, why is it 2 electrons? Why have we got 2 protons in there? Why is the water on the left hand side? Well, that's something that you'll learn from the redox topic in module 5. But if you are interested and you want the heads up, watch that YouTube video that will accompany this. Okay, but if that's the oxidation half equation, the reduction half equation is straightforward. We've seen that already. There's our silver ions being reduced to the silver atoms. Now, to get the overall redox equation, we would need to add these 2 half equations together, combine these equations. Now, when you add them together, we need to make sure the electrons are balanced, because if we're losing 2 electrons, we need to gain 2 electrons as well. So before we combine these 2 half equations, we would have to multiply the reduction one by 2. And that allows us then to cancel out those electrons, because an overall equation wouldn't have electrons in there, okay? So in effect, it's a little bit like you're putting a big number 2 in front of the Ag plus and Ag solid. You're balancing the equation. We now know in the background we're balancing it to make sure that the number of electrons being lost and gained are the same. Okay, so like I say, might have been a bit of a stretch at this point if we've not done module 5 redox, but there it is. Okay, the last question then, why do ketones not form a silver mirror? Explain your answer thoroughly. Okay, so we know that ketones can't be oxidized. Now, if we said that, that's correct, but it's not enough, because you're asked to explain your answer thoroughly. So ketones can't be oxidized, therefore the silver ions aren't going to be reduced, and that's why you don't get the silver mirror. Okay, so you're bringing it back to that original question being asked. Okay, so I'll just pause there for a moment then so you can make a note of that. And like I say, just highlight the ionic half equations as something to come back to or to watch that video on. That's the end of the carbonyls topic then. So time to check your progress using the learning outcomes on the front cover of your notes. You should now be able to describe and interpret the use of Tollens reagent, which remember is silver nitrate in ammonia solution, sometimes referred to as ammoniacal silver nitrate. Now we can use that if we want to identify an aldehyde. It detects the presence of an aldehyde group. So if you've got a range of different organic compounds, if you get that silver mirror, you know you've got an aldehyde. You can also use that observation to distinguish between an aldehyde and a ketone. So you might only have 2,4-DNP that you detect the presence of the carbonyl. You could then do a second test to distinguish between them. Okay. The other thing then is you need to explain the above in terms of oxidation of aldehydes to carboxylic acids and the reduction of the silver ions to the silver. So in the exam, they might ask you to give the structure of the organic product of that reaction. So you need to convert the aldehyde to the carboxylic acid to do that. Okay, so as ever, when you finish a topic, you should now pause and reflect on the whole thing. Make sure that you know the content of your notes, so check your notes are completed and understood. Make flashcards for any kind of key ideas. Maybe think of doing a poster or a summary sheet to pull all the key ideas together. And then, of course, it's time to practice. So can you now answer exam questions using your newfound knowledge? So there are some practice questions at the end of the booklet, and your tutor might wish to go through those with you on Teams. So once you've consolidated your knowledge, have a go at those practice questions to put that knowledge to the test. Good luck.